Yeah. Yeah, find the dimensions of the, oh, and plus they have width and length. Yeah, so that's helpful too. That's right, it says width and length. So they want the width and the length. I didn't even notice that. All right, good. Yeah, so they want the width and the length. Standard tennis court. What kind of a shape is a tennis court? I played tennis this last week. That's what I did with my break with my son. So what's that? What shape's a tennis court? Rectangle. So we're talking about a rectangle, right? We're talking about a rectangle. The length is 6 more than twice the width. The distance around it is 228. Okay. So rather than me diving forward, and I will, and I'll finish this up and all. Okay, how about I'm going to draw a picture for us. It's my best picture of a tennis court. All right? 228. So, any thoughts? What should we do? What do you guys think? What should we do on this one? Yeah, Giselle. Janelle, sorry. Janelle.
So if the length is 6 more than twice the width, then it would be 2w plus 6.
Okay.
You do 2w plus 6 plus w is, times that times 2 because it's a rectangle.
Good. So Janelle's thinking about some formulas. So Janelle's going with a formula approach. Is that what some of you are doing? That's a great way to do it. That's one of many good ways. Yeah. So Janelle's dialing in on that sentence. Length is 6 more than twice width. Let me bring that over. L is 6 more than twice W, right? Did I get that right? Yeah, length is 6 more than twice width. Length is 6 more than twice width. Yeah, Janelle, so what did you think to do with that?
So if you have 2w plus 6 for the length.
Okay, so let me stop you right there. So I just mean just that part. Yeah, is everybody tracking with what Janelle's doing? Is that what many of you did? Length is, what does his always mean when you see it in a word problem? Equals, right, we've done that before, that's not new. Length is 6 more is always add, right? Twice width, that's what Janelle is saying. Twice width, right? Are we good to there? Now that's length. All right, so what are we going to do with that? Can I give you, rather than just finish it, might help to label the figure, width. Well, it doesn't really matter what you call length and width, but I'll just go length, width. So what are we going to do from there? What's our plan from there? What can we do with that 228? Yeah. And how are you coming up with that? What they're saying distance around. So if you wanted to go, what's that called? What's the math word for distance around? Perimeter, right? Perimeter of a shape. Perimeter. Like they'll say the security guard walked the perimeter. That means walks all the way around a building, right? All the way around the outer edge. So if we start here, you can start anywhere. It doesn't matter. Start here, and you walk all the way around. That's the perimeter. That's the 228. Yeah, and so we have the length. The length here is 6 plus 2w. The length here is 6 plus 2w, right? That's what L is, we determined. And so we're going to add up all 4 of these, is what Giselle's saying. Exactly, that's one really good way. So 6, what's that? I'm sorry, I keep saying it wrong. Sorry, Giselle. All right, so add up those 4. There's too many Janelles and Giselles. I'm getting confused. All right, is 228. We good with that? Does that make sense? So I added up all 4 sides. This is one side, another side. Those are the length twice. There is the width twice. Has to add up to be 228. How are we doing? That's just the 4 sides added up. Any order doesn't matter. Okay, so can you solve that equation? Using your algebra skills? So what do we do? So using algebra, what do we do to solve that equation? Yeah. So there's these W's Like terms, right? 2W, 2W, 1W, 1W adds up to be, I don't know if you can read this as a 2 here, adds up to be 6W, right? We good? 6W plus, and then what else is there? 12. Everybody agree? 6 and 6? 12. That's 228. So what do we do now to solve for W? Yeah, right. Subtract the 12 from both sides. And we get 6W. These are gone. What is that? 2, 1, 6. Last step to get W alone. Divide, right? You good with all this algebra background stuff? Remember all this? Divide by 6 on both sides. So W will be, what is that number? 36. That what it is. Thank you. 36. So W is 36. So the width is 36. So we've got the width. What else? Well, they want the length, don't they? How are we going to get the length? Plug it in. Are we good with that? Is that good? So I'm going to go to a fresh screen. So we have width is 36. And we already know length is, from the formula right here, 6 plus 2W. 6 plus 2W. So I'm going to grab that width and I'm going to plug it in. So 6 plus 2 times W. 6 plus 72. And that is 78. So the length is 78. The width is 36. We've answered the questions. Is that good? Did anybody do it a different way? Certainly you didn't all do it exactly that same way. Is there some other variations? Even if you just started a different way? Anybody just like use the perimeter formula from the beginning? You guys might know the perimeter formula. What's the perimeter formula for a rectangle? 2L plus 2W. That'd be a slight variation. It's pretty much the same thing. You could just start with that. And then just go. That'd be almost the same thing we did. We just kind of looked at the picture and did that, basically, right? Any other ways? Anybody did that? Is that good? Is that making sense? Questions on that? All right. I'm going to move to number 2 if you're good with that. So there's going to be a variety, but these are all going to be different. So that's what's special, and that's what's kind of long about this section. These are all going to be different. This is problem solving. So number 2, a rubber ball. Can you read that okay? A rubber ball is dropped from a height of 176 feet. Each time it hits the ground, it bounces back 1/2. Looks like there it is. A rubber ball is dropped from a height of 176 feet. Each time it hits the ground, it bounces back up to 1/2 of its previous height. How far off the ground will the ball be after it has traveled 500 feet? Answer? No, I'm just kidding. I'm sorry. This is a longer problem. We need to think it out, right? All right, so let me give you clear on that. So it's dropped from 176 feet. So on number 2, we have this ball up here. Let me get you started on the picture. And then we're going to drop it, right? Let's just say it's dropping down. And it's going to bounce. And this height here is 176 feet. And it's going to bounce. And how high up is it going to bounce? Half, yeah. So, come down here, find a half of 176 by hand or by calculator. What's that going to be? It's 80 and 84? No, that's not right. 88? Yep, 88. So it's going to bounce up this distance, 88 feet, isn't it? You with me? So a lot of solving a problem for stuff is just being really clear what they're even saying. Are you getting the hang of what they're saying? It's gonna go down 176, bounce up 80. And now what's their question? Let's go back to the question. What do they even want from us? Are you clear on the question? What's the question? What do they want from us? Yeah, how far off the ground? When it's traveled 500 feet. What do they mean traveled 500 feet? Are we clear on all those words and what they're even saying? What do they mean traveled 500 feet? What did the ball, and they mean vertically travel. They mean up and down. So I probably shouldn't have drawn it sideways, but they mean up and down. So right here the ball traveled down 176 feet, and then it went up, how much? 88 feet. So could I keep track of how far the ball has traveled so far? 176 plus 88. Somebody have their calculator? What's the running total to here? 240 and 24, I think. Isn't it 264? Am I doing that right? Yeah. So to there, the running total is 264. Good. Now what do we want? We want to know when it's traveled 500 feet. 500 feet. So with that. All right, it's going to come down. 88. So what's the running total there? 352? Am I doing that right? Okay, 352. How far do we want to go? 500, right. Okay, so then it's going to come up 44. So add 44. What's that? 396. Come down 44, which is another, I don't know, 440? 440 feet at this point. Total up and down travel. Again, we're just assuming the ball's really going straight up and down. So total 440 feet of travel when it hits down here. We good so far? See how I'm just drawing this out? So the strategy I'm using is really just drawing a diagram, isn't it? Not using variables. I'm just drawing a diagram. All right, let's keep going. It's going to come up. How high is it coming up? 22 and down 22, up 22, down 22. So I'll add a couple 22s. I don't think we're at the total yet. 44. That'd be 484, right? Bless you. So we're at 484. These lines are my total mark. So to here, we're at 484. So we're getting close to 500. Let's keep going. It's going to come up 11. So when it comes up 11, we're getting really close. The total to that point is 495. Right? So it came up 11. I think we need to blow that little picture up. So let me put a little picture there, and I'm going to just show that last thing. It going up. I'm magnifying it. It goes up 11, because this is where it's going to finish, huh? This is where it's going to hit at 500. Is in the descent from the top of that 11. So it's right there. It's at 11. It's up 11, and it starts coming down. And right then, it's at 490 feet traveled. And we want to know where is it when it, boom, hits 500. So it's going to come down how many feet? 5 more feet. 5 feet down right there. When it comes down 5 feet, it'll hit the magic 500. Like when your car turns over at 100,000 miles, right on the money. Right there, the ball just traveled 500 feet. And so the question is, how high is the ball? If you could freeze it, like a video. If this is a video of this ball going up and down, up and down, up and down, and you freeze it, right when that ball's in midair. It's what I'm always doing with my daughter's taking physics. I'm helping her. And these things are moving, and they ask you a question. I'm always, how do you imagine freezing the frame? So that's kind of like what we're doing right there. It's a video, and we freeze it right there. How high is that ball off the ground? Right at that moment. It's got to be 6 feet, yeah. See how we're getting that? Because it's 11 feet. Came from an 11 feet height. Came down 5 feet. It's got to be 6 feet above ground right at that moment. Are we good with that? Does that make sense? We're going to do that strategy on a few of these problems. That's one of the major strategies. And really, it's almost part of every problem I solve. Whenever I dive into like a brand new problem, I try to draw a picture. It's just helpful to see stuff. And it's really all of this problem is drawing the picture. Well, and keeping a running total. Questions I can answer on that one? Is that making sense? We good? All right. It's only 2 problems in 25 minutes. Okay. So suppose a giant outdoor circle has numbers all around it, starting at 1, 2, 3, etc. if the number 3 is directly across the circle from the number 15, how many numbers are around the circle? Hint, draw a picture. So that's why I wanted to do another. This is another draw a picture. This is all about a picture. So see if you can draw a picture. Even if you think, how will a picture, even if it makes no sense, just start drawing. It's amazing what will happen for you if you start drawing. Just start drawing a picture. This is like a cakewalk. Can you picture it? Let me help with that. So what do they mean? Let me draw a circle. It's going to tax my artistic skills to the max. I told you about my art career, didn't I? Did I tell you that, Mama? That it ended in the 7th grade with a C? That was it. I was trying too. All right. So that's not a bad circle for me. All right. So what do they mean by that the 3 is directly across from the 15? What do they mean by that? 3 is directly across from 15. Directly. Do they mean like 3's here and 15 straight across like that? They don't mean that, do they? What do you get what they mean? What do they mean? What's that? Through the center. Exactly. Directly across is meaning through the center of the circle. Like that. Is everybody good with that, what they mean by that now? So directly across, when you talk about a circle, means through the center. Okay. I'm going to fill them in here. I don't know if I'll be very evenly spaced, but I'll do what I can. So number 4, number 5, number 6, number 7, number 8. I better start going smaller. Number 9, number 10, number 11, number 12, number 13, number 14. So it's not so evenly spaced, but you get the idea. Okay. So far, so good. It's got to be, right? Nothing amazing yet. So what? How can that help me in any way? Yeah. I don't know if you can hear what Janelle's saying. She's trying to broadcast what I'm saying. Okay, no problem. She's observing that how many dots are over here? It's got to be the same amount on the other side because this is going through the center, isn't it? So can we count how many dots are over here? How many we got? 1, 2, 3. I'm just counting the dots now. 4, 5, 6, 7, 8, 9, 10. 11 dots on that side of the circle. So there's got to be 11 dots on the other side of the circle, doesn't there? Okay, so what? Well, there's 2 dots. 3, 4, 5, 6, 7, 8, 9, 10, 11. My spacing's way off. There's 11 dots on the other side. Are you tracking with me? So 11 dots on one side. 11 dots on the other side. Now, how can we finish that problem? So let me give you just a minute. The numbers. Are we good? We getting them? This has got to be 2, 1. What's the next number? Yeah, I don't know. What am I going to do? Yeah, go down to the 15, huh? 16, 17, 18, 19, 20, 21, 22, 23, 24. So what was their question? How many numbers around the circle? Answer is 24. Must be 24 numbers around the circle. How are we doing? Is that making sense? Drawing a picture there? See how that strategy works to solve the problem? Yeah, Janelle. How'd you do it?
Just subtracted 3 from 15 and multiplied that by 2.
Say it one more time.
Subtracted 3 from 15 and then multiplied that by 2.
Subtracted 3 from 15, which gave you the answer 12, and then multiplied that by 2, which gave you 24. Boom, you were done. No picture needed. What do you think about Janelle's method? Do you like hers better or mine? I'm just joking with you. That's very fast, isn't it? That's very fast. Now, let's see why. So she took 15 minus 3. Why? Why, Janelle? Why did you take 15 minus 3?
Because it gave you the number 3 and the number 15 are directly across from each other. So
Right, as we see here, 3 and 15.
between them is half of the numbers, including one of them. So half of the numbers are
Yeah.
either the other.
So Janelle said an interesting phrase there. She said if you subtract 15 minus 3, 15, making that very neatly, 15 minus 3, and you get 12, you get half the numbers between them, and then I was listening and she did a good job. She added including one of the numbers. That's really important that she observed that. You know what I mean? If you just say that's half the numbers, what do you mean? Do you mean half just these, not including the 2 endpoints? Because that matters for the total, doesn't it? So she noticed that when you subtract 15 minus 3 and you get 12, 12, for example, would be all of these stopping there, but including that one, or you could include the other endpoint. It doesn't really matter. But including one endpoint, that's 12 numbers. How do we know? Well, because remember, we counted from here to there is 11, so one more is 12 numbers. Why does that matter? Well, because that's exactly half the total, isn't it? Because the other group is exactly the same thing. Do you see that? It's this endpoint all the way to there. That's also got to be 12. So she said you can just double that and you get 24. That's really good. With that kind of strategy, without seeing a picture, you have to be really careful, though, to make sure you've got the half that's the correct half. And you're including endpoints or not including endpoints. She knew. But if you were going to use that, I would be careful with that strategy to make sure you're doing the right thing with the endpoints. Janelle handled it well, but might not always be easy. Good. Other comments on that one? So that's great if you can picture all that. All right, how are we doing? 15 minutes. All right, maybe 1, maybe 2 more. Let's see what we can do. So, number 4. Suppose that on a balanced scale, 2 gold coins weigh the same as 5 black buttons. And 1 pair of scissors and 1 gold coin together weigh the same as 7 black buttons. How many black buttons weigh the same as the pair of scissors? So let me let you digest that, and let me write it. How about I write out the key facts, which I'm sure a lot of you guys are doing. 2, what does it say? 2 gold coins, 5 black buttons. So I'm going to go, number 6, number 4. So I'm going to go 2 gold coins equals 5, let's call B for black buttons here. So 2 gold coins, 5 black, they're equal, right? Weighs the same as. And 1 pair of scissors and 1 gold coin. One pair of scissors. 1 pair of scissors and 1 gold coin is 7 black. Okay. 1 pair of scissors and 1 gold coin is 7 black. 2, 3, 4, 5, 6, 7. Are those the key facts? Yeah. And then they're saying how many black buttons is the same as a pair of scissors? You always got to be clear on the question. So the pair of scissors is how many black buttons, right? So we good with the facts? I got the facts down? Good. 2 gold coins is 5 black buttons. A pair of scissors and a gold coin is 7 black buttons. 1 pair of scissors is how many black buttons? That's our question, right? All right. So what do y'all think? What'd you come up with? There's a lot of ways. There's not just one right way. There's all kinds of ways. Any thoughts? We can't rely on Janelle for everything. We got to get somebody else to carry the responsibility. What do you think?
Find out how much 1 gold coin weighs.
Good idea. That's a good way to go. Okay. Yeah, so how can we do that? How can we find out how much 1 gold coin weighs?
So divide
Jesus?
black coin by 2.
Yeah. So, So what'd you come up with? So what does that result for you, Jesus?
2.5.
Yeah. Everybody see what's happening there? He's basically saying 2 gold buttons is 5, or gold coins, whatever they were, is 5 black buttons. So each of those gold coins is 2.5 of the black buttons, isn't it? Right? 2.5 and 2.5 is 5. Right? So 2 gold coins, 2.5 is 5 black buttons. Good. And then where do we go from there?
Subtract it from the black buttons on the bottom to get your scissors.
Say that one more time?
Subtract the black button weight to get your scissors.
You're talking about the second equation now?
Yeah.
Okay, so what do I do? Subtract 2.5 from both sides? Kind of like an equation? Is that what you mean?
7.
You'd rather me write it like this, huh? 7b, kind of like that? Yeah, all right, I'll do that. That's probably a good idea. And so then what do? I subtract. You're saying subtract. Let me change my color here. Subtract the this fact, bring it down, and subtract 2.5b from that side. But remember, when I deal with an equation, I have to do the same thing on both sides, don't I? So what do I do on the other side? Take off the goal. Is that what you're saying, Jesus?
Yeah.
And that is the same, huh? Jesus is right on the money. That is the same. Sorry, that was a pun. No, all right. Anyway, so it's money. Sorry. All right. Anyway, so that's right. See what Hosea is saying there? 1 gold coin is 2.5 black buttons. So these things are equal, aren't they? This gold coin is 2.5. Or how about if that's confusing for you? Because I know exactly what Hosea is saying. I just want to make it clear for everybody. The gold coin is, what is the gold coin? 2.5b. We could put it right there, like that. Is that making sense? All right, maybe I'm overdoing this. So at this point, Jose's like, all right, so subtract it. So subtract the 2.5b from both sides. So what do the pair of scissors equal? What is that? 4.5 black buttons. Exactly. Is that good? Does that make sense? I'm sure there's other ways we could get gotten there. Good. All right, I'm going to start one more. So I'll read it and then I'll write a summary. So just listen to me read it and then I'll write a quick summary for you. 2 hot air balloons are off the ground. On the first balloon, the distance from the bottom of the basket to the top of the balloon is 15 feet. Let me go do that real quick. So on number 5, problem number 5, balloon number 1, from the bottom of the basket to the top of the balloon is 15 feet. Bottom of the basket to the top of the balloon is 15 feet. Fact number 2, for the second balloon, this distance is 20. So balloon number 2, this distance, bottom to top, is 20. The top of balloon 1's balloon is 6 feet above the bottom of balloon 2's basket. The top of balloon 1's balloon, so let me write that down. Top of balloon, top of balloon number 1's balloon is, what did they say? Top of balloon number 1's balloon is 6 feet above the bottom of, is 6 feet above the bottom of balloon 2's basket. Did I get that fact right? Is 6 feet above the bottom of balloon 2's basket. Right. If the distance from the ground up to the bottom of balloon 1's basket is 50 feet, so let me write that down. Ground to bottom of balloon 1's basket equals 50. Is that right? If the distance from the ground up to the bottom of balloon 1's basket, 50, right. How far is it from ground to the top of balloon 2's balloon? So that's the question. How far ground to top of balloon 2's balloon? To the top of balloon 2's balloon, exactly. Okay. So there's the key facts. I don't know if I made that smaller much. Still a lot of words. All right, let me give you a second. We've only got 2 minutes. Okay, so write that down. What strategy might you use on this problem? We're going to need to finish it next time, but let's spend 2 minutes. Spend 2 good minutes on it. What in the world strategy, as you read this problem, you want to be thinking, okay, kind of a crazy question. What do we need to do? Yeah, we have got to see a picture, don't we? I mean, who in the world can read all those words and keep all that straight in their head? Nobody. You need a picture. And you need a picture careful. Can you start, we get 2 minutes, can you start drawing a picture of what they're saying and put all those little numbers in the picture? Let me help you with what I mean by the picture. We're going to have ground. Oops, my ground's not too level there. Going to have ground. And we're going to have balloon number 1. Now, what do these balloons have? They have hot air balloons. They have a basket and a balloon. Now, I'm going to have to adjust my balloon probably several times. But I'll just say, hey, there's number 1. And they're obviously not at the same height, are they? I don't know the detail. I have no idea. Right now, that could be completely wrong. I'm just getting going. And that's what you want to do when you're solving a problem. Just keep going. Don't try to have everything in your head perfect. Things will sort out as you go. So I might have it totally backwards. 2 might be, I think 2 is backwards. I think that's totally backwards. Whatever, that'll come as we go. Just put that down. Start putting some measurements. Start adjusting, changing pictures as we go. So there's that. So we let you put a couple things on your picture. So how about this first fact? Bottom of basket to top of balloon number 1, this is balloon number 1, is 15. So, how do I put that? That's balloon number 1. Doesn't that mean this right here? Do you see that? Do you see how I'm using double-sided arrows there? That's really helpful. Let me really encourage you. I know that seems small. When I teach calculus, I'm always telling, like I would have my students in calculus, higher math, you do this kind of thing all the time. You have pictures and diagrams. And I have students all the time, they'd go, 15. And, I'd help them in office hours and I'd go, well, what is that 15? Is that like the height of the balloon? Or is that so you don't want to just write down 15. Double-sided, that's what engineers do. They use double-sided arrows to be super, super clear. From here to there is 15. That really is helpful. We're out of time, aren't we? All right, so we will...